All right, so I'm going to, sometimes when you hear something again or a slightly different way, then it starts to connect and make sense, okay? So I'm going to be just reinforcing some of the things that we've already been doing. So this is kind of going back to factoring, okay, and simplifying. Those are the foundations for this, because if we need to be able to do both of those things really well and stating non-permissible values, because we use it when we multiply rationals, divide rationals, add and subtract rationals, which is all like this coming week, and then doing problem solving, okay? This unit, just so that you guys know, this unit is usually like a quarter of your diploma. Okay, there's a lot of learning outcomes from it, and so they ask a lot of questions from this unit. Okay, so this could be an opportunity for some of you going, I get this stuff, we're rocking. This could you could do really well. If there's something that's not making sense, do yourself a favor, okay, come in at scheduled help and ask a question, get some clarity on it. Okay, ask your elbow partner quietly when you guys are working on stuff, just to have a different voice kind of explain it to you. Okay, so one of the things that I want to make sure that we're clear on is just some terms. Okay, I'm going to use the word, where am I going to put this? Here, I'm going to create a new page. Okay, don't forget, okay, we're going to talk about monomials and binomials. Okay, our next unit is actually about polynomials. So these words are just, okay, our fancy words. So a monomial just means that there's one term, right? One term meaning it could have a coefficient, okay, and some variables, but everything in that term is just all connected by multiplication. So for example, 2x, that's a monomial, okay? X squared, that would be a monomial. Okay, compared to a binomial means that there's two terms that are connected by an addition or subtraction. So for example, x minus 2, this would be a binomial because there's a subtraction, and that's why we use brackets in order to separate our binomials from our monomials. Okay, so when we have been doing our simplification, okay, when you simplify, you have to simplify a binomial with another binomial. Okay, there was a question that was asked, right, where we had something like this, like a minus 3 divided by a. Okay, and we were like, oh, can we cancel the a's? Okay, this is a really common mistake, so I want to make sure that we're understanding why we cannot. Okay, we can't just cancel the a's, because this is a binomial, and this little guy down here is a monomial. Okay, and they have to be exactly the same in order to cancel them. Okay, so put brackets around your binomials when they're connected with an addition or subtraction. Here's another example of a binomial. It could be like 2x plus 4. Okay, it could be something like 3a cubed minus 4a, right? There's a binomial. Bi just means two, like a bicycle, two wheels. Okay, it just has two terms in it. What do you think you call the thing that has three terms in it? Trinomial, exactly. Once we get past 1, 2, and 3, that's where we use the word poly. Polynomial just means many terms. Okay, so all of these are just special types of polynomials. So I just want to make sure that when we are simplifying, that we are, if it's a binomial, the only thing that will cancel out with a binomial is another binomial. Okay, we can't just suddenly take our monomials and start crossing things out. So let's go back and take a look at, okay, our questions. Okay, so I'm going to do a couple with you just to get us warmed up, and then we're going to head to the boards. Okay, so the first thing that we're going to do, right, always the first thing that we're going to do is we're always going to factor. Okay, and so when we factor, we're looking at the top, and we can take out, okay, don't forget when you're doing these, you're going to line up your equal sign on the left-hand side, because you're basically writing equivalent expressions. Once you factor it, that's just an equivalent expression. So don't forget your equal signs. Okay, and we're going to take out a 6x, and we're left with an x plus 4. Okay, a GCF, guys, is always a monomial. Okay, a GCF is always a monomial. So you're going to notice that there's, okay, our binomial, when we took the GCF out, it becomes this. Okay, now before we do any simplification, this is where we would do our non-permissible values. Okay, if you want, you can kind of look at it like this. Our monomials, you could have, like, you could put brackets around. Do we have any problem with the 6? Are there any issues with the 6 on the bottom? No, there's no issues. So we don't have to do anything with the 6. The x is the problem, though. Okay, what can x not be? Yeah, x cannot be 0. Okay. Now, what if it was x squared, or x cubed, or x to the power 7? Okay, it's still just x is on the bottom. Okay, so those examples, doesn't matter what the exponent is, it's still going to be x is equal to 0. All right. So now, when we simplify, okay, we could do the same thing. We could put brackets all around our monomials, okay, and our monomials will for sure cancel out. Okay. Now, what's left on the bottom when I cancel these things out? Yeah, okay, 1 is on the bottom, 1 is up here. So technically, this is all over 1. Okay. However, when we write numbers, do we need to write the over 1 part? No. Okay. So you guys are good for that. All right. So for this one, same thing. We're going to factor first. We're going to state NPVs. Then we're going to simplify. Okay. When it's already a monomial, there's no factoring. Okay. You can't factor a monomial. You can't take anything more out of it. So when you see that there's only one term, it's already done. Okay. So here we can write our monomial. Okay. And then we take our GCF out. Okay. And we're looking at 21A and 28A. Okay. What's our GCF? Our number? What can we take out of both of those? 7. Yeah. Can we take out some A's? Yeah, 1. Yeah. Because we go to the lowest exponent. Absolutely. Okay. So we're left with a 3 and a 4A. Okay. So now we do our non-permissible values. Okay. And let's just look at this. Okay. I'm just breaking up my monomial and putting each term in brackets. Do we have any issue with the 7? No. Okay, so we don't have to do anything with the 7. How about the A? Yeah, A can't be 0. Okay, and what about this binomial? Okay, that's where we put the binomial can't equal 0. Okay, and then we can say, let's put the 4A on this side. So we have 3 is equal to 4A, divide by 4, divide by 4. Okay, so A cannot equal 3 over 4. Okay, so we have our 2 restrictions. Awesome. Okay, and now we can cancel. So we have a 14 up here, and the 14 and the 7. Right, we can do 14 divided by 7. That gives us 2. Here we have an A down here, and that takes out one of the A's up at the top. Okay, so we're left with an A at the top, and then we still have this binomial on the bottom. Okay, and then our restrictions, not X's, we're doing A's. Okay. So this is what we've been working on for the last few days, right? Factoring, non-permissible values, and then simplifying. Okay, we'll do one more and then I'll get you guys up and out of your seats. So this one, same thing. Okay, we have a binomial on the top and a binomial on the bottom. We always check GCF first. Okay, what's the other factoring method that we use? Like, what are we going to use on this x squared minus 25? Difference of squares, yeah. Okay, so we can take a 3 out of the top. We've got an x plus 5. Difference of squares, we have an x plus 5. X minus 5. Okay, what are our non-permissible values? Yeah. 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 Okay. So x cannot equal plus or minus 5, okay, based on these guys. Now we can simplify, okay, and we have a 3x. Okay, guys, can we simplify? Can we cross out our x's because there's an x on the top and an x on the bottom? Why not? Yeah. Okay. This guy here is a binomial. Okay. You cannot cross anything out of your binomial. Okay, unless it's another identical binomial. So I love how you guys recognize that this is connected with the multiplication, this is connected with the subtraction. So when there's like different connecting points, you can't just start crossing them out, okay? Okay, so head to the board. You guys get to do the next 3. I'm gonna come around, chat with you, see how things are going. Okay, so start with the 9m to the power of 3 plus 15m to the power of 4 all over 6m squared. Okay, so you're going to factor, you're going to state the MPVs, and then you're going to simplify. I was like, do I need to make it bigger? To the power of 3, and then plus 15m to the power of 4, all over 6m squared. Yeah. You're not going to fall asleep in my class, are you, Lachlan?
I might.
Yeah. I'll just come by and elbow you.
Oh, okay. I should probably, yeah.
Okay, you need to be doing this, though.
Yep.
Like, there's a pen right here. You do it alongside Bianca. Okay, I need to see it because I know this is not your favorite unit.
Yeah.
I'm not going to make it your favorite, but we're going to, like, succeed.
Mm-hmm.
So, guys, with dividing rational expressions, okay, we're doing every single step the same that we did when we were doing multiplying. There's 2 things that we're adding to this one, okay? The first thing we have to do is remember how to divide fractions, okay? What is the big thing when we divide fractions? So when you see the word quotient, okay, this is just the fancy word for divide. Okay, so if it ever asks you, like, what is the product between these 2 rational numbers, that means that you multiply them. If it says, what is the quotient between these 2 numbers, and you have to interpret that, and that means divide. Okay, so sometimes in a word problem, it won't give you the operation, it won't show you the multiplication, it'll use the words quotient or product. So make sure that we can interpret those. Okay, describe a strategy that could be used as a method to divide rational numbers. So let's take a look at this fraction. Okay, when you guys were in junior high, okay, maybe even in elementary school, they probably started teaching this, I'm going to guess like grade 6, grade 7. Okay, we learned that when we divide by a fraction, what do you guys do? Do you remember? Yeah, okay, so some people have different terminology. Okay, your teacher might have said kiss and flip. Anybody, did you guys get kiss and flip? Yeah, some of you got kiss and flip, which meant that you changed the division to a multiplication, and then you flipped the second number. Okay, some of you, your math teachers gave you a little bit more mathematical language. Maybe they said change flip. Okay, maybe they said multiply by the reciprocal. Did anybody get the official multiply by the reciprocal? Okay, they kept it kid friendly. All right, so those 3 ways to describe it, I will probably just remind you to kiss and flip, okay? But it means, yeah, that you're going to keep the first one, change the sign, and then flip the second exponent. So now that we have a multiplication again, we know how to multiply our fractions, right? When we multiply, we just multiply straight across the numerators and straight across the denominator. Okay, so in this case, we would have 12 over 3. And then, do we need to simplify? Always. Okay, it will never, I don't have to remind you. Okay, you will always simplify when you can. So in this case, 12 divided by 3 is just 4. Okay, so when you're doing your rational expressions, okay, you always need to keep on going until you are at like the most simple it can be. If there's a GCF that you could still take out, okay, because you didn't take out the greatest one the first time, you have to still take it out. If you take out a GCF and then you notice, oh, there's a difference of squares, okay, that's your second step, and then you need to take the difference of squares. Okay, so what we're going to do, so here is our strategy. You're going to multiply by the reciprocal. I always spell this one wrong. Reciprocal. There we go. Multiplied by the reciprocal. Okay. Okay, some people know it as keep, change, flip, or kiss and flip. Okay. Now, okay, so here's what we're going to do when we are dividing our rational expressions. Here's our rational expression. Here's what a sample question would look like. Okay, guys, just take it one step at a time. Okay, the first thing that you're going to do is you're going to factor all of your expressions, whether they're in the numerator or the denominator. You're just going to factor them all. Okay, if it's a monomial, okay, you don't need to factor a monomial. You just write that. Okay, and then you're looking for GCF or difference of squares. Okay, so the first thing we're going to do is we're going to factor this. So on the top we have a monomial, so we can just write it. On the bottom, I'm seeing that we have a GCF. Okay, we can take out a 4, and we can also take out an x. So we have a 4x, and then we're left with 24 divided by 4 gives us 6. X divided by x is just 1. And then I have 4 divided by 4 is 1, and x squared divided by x is an x. Okay. The 1 is optional. Okay, obviously there's still 1x, whether I write the 1 or not. So if that, okay, you can just write 6 plus x. Okay, you're still going to write the division sign. We're not changing anything yet. We're only in this step, we're only factoring. Okay, we're going to factor at the top. We have a greatest common factor, 6x. And we're left with x minus 1. And on the bottom, we can factor the same thing. We're doing a GCF again. Okay. What can we pull out of this denominator? What's our GCF? We've got 9x cubed and a 54x squared. I heard that from Rain. Yeah. Okay. Yeah. 9x squared. We have an x plus 6. Okay. Step number 1, factor all expressions. Check. Okay. Now we state all the non-permissible values. Okay. So again, just the things in the denominator. Okay, so are we concerned about the 4? No, the 4 doesn't matter, so we're just looking at the x. Whenever there's an x on the bottom, x cannot be 0. Okay, then we have this binomial. So we set the whole binomial. It can't equal 0. Okay, so then that means that x cannot equal negative 6. Okay, and then we pop over to here. Okay, we have to find the non-permissible values of both rational expressions. Okay, the 9 is fine. We don't have a problem with the 9, but we have an x squared. Okay, are you going to ask her to the bathroom? Okay, not during the lesson. Okay, and then after Jadalyn. Okay. Okay, so we have this x squared. So x cannot equal 0. Guys, if you already have it written down, you don't have to write it twice. Okay, so we already have the x cannot equal 0 taken care of. And now we have this binomial, which is the same thing. X plus 6 cannot equal 0. So x cannot equal negative 6. So we've already done both non-permissible values, so we're all done with this one. Okay, now we're going to take the reciprocal of the second expression and multiply. So this is now where we're going to kiss and flip after you've done your non-permissible values. Okay, so you're going to have 2x, 4x, Okay, guys, can I just rewrite this because it's addition? Can I just write it x plus 6? Okay. And then I'm going to multiply by the reciprocal. So the 9x squared, x plus 6 comes up on top. And the 6x, x minus 1 is on the bottom. Okay. Okay, guys. So that was the first thing that we added, that we've done different. Okay. We multiplied by the reciprocal. We did our kiss and flip. So this is new. Okay. State any additional non-permissible values. So we just flipped that second term. We now have a new denominator in play. Okay, so now we have to go to here and we have to state any new non-permissible values that were just introduced into our expression. Okay, we have a x can't equal 0 on this one. Okay, so here x can't equal 0 and x cannot equal 1. Okay, the x cannot equal 0, we already have it in our list. And so this just introduces one more non-permissible value. Okay. So x cannot equal 0 was already in the list. So x cannot equal 1 was new. I'm just writing this down for you guys. Okay, was a new NPV. Okay, now we can simplify the expression. So now go ahead and if there's any binomials on the top that exactly match a binomial on the bottom, we can cancel those. Okay, has to be exactly. Okay, so this x plus 6 and this x plus 6, those can cancel. Okay, we can also cancel out any monomials, okay, and any numbers that we have. So here's an x and here's an x. Okay, so we can cancel those. And here's an x on the bottom, and that takes care of one of these squareds. So we can go 2 minus 1, which is what? Okay, and so now we can just multiply across. Okay, if you want, okay, you have two choices. You can still simplify your coefficients, or you can just multiply everything across and simplify at the very end. Okay, and have your calculator help you with that. Okay, so if you want, you can do 18. So 2 times 9 is 18. There's an x up there. Okay, and then on the bottom, 4 times 6 is 24. And there's an x minus 1. Okay, so with your calculator, you're just going to go 18 over 24. Okay, 18 divided by 24, and then you're going to go math fraction. Okay, and it reminds you that when we simplify 18 over 24, right, we have divided both top and bottom by 6. And so we end up with 3/4 as our simplified fraction. So this becomes 3x, 4 on the bottom, x minus 1, comma, x cannot equal. Okay, and then go back to your list. It cannot equal 0, it cannot equal -6, and +1. I'm just going to put them in order. Okay. So there you have it. Yeah.
You can also cancel out like 6 plus x and x plus 6 because it's the same thing.
Yes. Yeah, so I just, because it's the same thing, that's why I rewrote it.
Yeah. Okay.
To make it like that. Yeah. Okay. Okay, so let's do a few more together. Okay. Whoops. There we are. All right. Okay, so the first thing we're going to do, we're going to factor. Then we're going to state NPVs. Okay, so if you feel like you're getting this, go ahead and work a little bit ahead. Now I'm looking at this and I'm like, okay, here's my binomial. Guys, is there any factoring that's needed on A, or is it already in factored form? It's already in factored form. So this one is just kind of getting us used to it, and then we're going to add some more factoring in. Okay, so this one's already factored. We just have to state NPVs. Okay, remember they're only of the denominator, so we have 2x minus 5 cannot equal 0. Okay. Okay, so that means that x cannot equal 5 over 2. And we have an x on the bottom, so x cannot equal 0. Okay, then it said that we are going to kiss and flip. So we're going to change our division into a multiplication, and we're going to multiply by the reciprocal. Okay, so this becomes, I'm going to write it way over to the left here, x minus 3, 2x minus 5 times x over x plus 1. Okay, guys, if this multiplication, like when I look at it, it kind of confuses me. It looks like my x. If that's the same for you, you're welcome to use a nice dot, because that also means multiplication. Okay, so I'm going to start using the dot to show my multiplication. Okay, at this point, I have just flipped my second rational expression. I just introduced a new non-permissible value. Okay, so we have to add that to the list. X plus 1 cannot equal 0, so x cannot equal negative 1. Okay, now I'm ready to simplify. Okay, these are all my binomials, and I got one little monomial up there. Is there anything I can simplify? Are any of my binomials the same?
No.
No. Okay, so this one was kind of, I think it's fun to cross things out. So this I would say this one's boring. Okay, there is nothing to simplify. So then our answer is simply x minus 3. Oh, hey guys. So it's x minus 3 times x. But where do we normally like write the monomial part? We write it before the binomial. So just to clean this up, I would write the x first, x minus 3. Okay, and then on the bottom, this one you don't have to, unless there was a monomial, you would write the monomial first. Okay, and then you would just list your x cannot equal negative 1, 0, and 5 over 2. Okay, does order matter on your restrictions? No, it's just convention. Okay, I'm not going to take off a mark if you did it in the order that you solved it. Okay, but you're just going to notice that I'm going to write it in ascending order. Okay, how's that? Okay, so our next step, now we're going to do some factoring. And then this last one, we've got just a little bit of weirdness going on that we'll do together. Take a look at that. Okay, so if you're feeling good, go ahead and factor B. Okay, you're going to factor it, and then you're going to state your non-permissible values. B. B for Bob. At the bottom. All right. Okay, I'm taking a greatest common factor of 3x out. Okay, so this is my factored form, and I'm ready to state NPVs. Okay, so I have x cannot equal 0. Okay, that takes care of this monomial. And then I have a x minus 3 cannot equal 0, so that means that x cannot equal 3. Okay, and these are the same, so that takes care of both of them. All right, so once I've factored, stated my NPVs, now I'm ready to kiss and flip. Okay, so x minus 5, 3x, x minus 3 times the reciprocal all over negative 5. Okay, did this introduce any new NPVs? Okay, there's now a -5 on the bottom. Do we have a problem with a -5 on the bottom? No, only if there's a variable. Okay, so this question did not introduce any new NPVs. So you might want to make a note to yourself. Okay. You don't have to tell me that, but this is just for you to, as you're going through your notes, to make sure that you understand. Did not introduce, okay, any new NPVs. All right, now we're ready to simplify, okay, and then write your answer. Okay, so we can go ahead and there's a x minus 3 on the bottom and an x minus 3 on the top. Okay, guys, can I cancel this x and this x? There's one on the bottom and there's one on the top. Why not? Okay, because this one is part of a binomial. You did. Okay, your instinct is good. Okay, you can't just cross things out if they're connected with any other numbers. Okay, so let's go ahead and, okay, now here I can do the 6 and the 3. Okay, so I can go 3 divided by 3 is 1, 6 divided by 3 is 2. Okay, so I could simplify that ahead of time. Okay, and so here, what am I left with? I'm left with the 2 on the top and an x minus 5. Guys, do not forget the brackets. Okay, the 2 is one number and it's being multiplied by your entire binomial. So don't forget the brackets. Okay, and then on the bottom we have an x and we have a -5. So we would write the -5 first and the x. Okay, what's the final thing that I need to do for this one? To like finish the simplifying. Okay, convention says that we don't keep negative signs on the bottom. Okay, so we just need to float this negative sign up to the top. Okay, so we have -2 x minus 5 all over 5x.
Oh, you split the negative out.
Yeah. Now, if the numerator was negative, then you would do like a negative times a negative and it would become positive. Okay. And then we would just state our NPVs. X cannot equal 0 and 3. Okay. Yes. We're still in the lesson. Can you just wait till we're done that? Okay. All right. Let's do C, because there's, okay, we've got this divided by just an A, and then we've got this +3 kind of hanging on. So let's see what we would do for that. I'm just going to rewrite it on another page so that we have lots of room. Or I have lots of room. Okay, so here's the original question. A minus 6, okay, 3a squared plus 9a divided by a plus 3. Okay. So guys, okay, first thing you're going to do is you are going to factor. Then you're going to state your NPVs. Okay, so we have a binomial on the top, which is fine. We're going to take out GCF on the bottom. So we have a 3a, and we're left with an a plus 3. Okay. Okay, our NPVs, right, are only on the denominator. Okay, the restrictions are only on the denominator. So we have an a cannot equal 0. That takes care of this guy. And we have the binomial, a plus 3 cannot equal 0. So that means that a cannot equal -3. Okay, so we have 2 restrictions. Now we're ready. Okay, don't forget order of operations, BEDMAS. Okay, it says that we have to prioritize multiplication and division before addition. So we're going to do this thing. We're going to do the division first, and we're going to wait until the very end before we do the +3. Okay, so we're going to go a minus 6 all over 3a, a plus 3. Okay, make sure I'm on the right track. Yep. Okay, and oh, I see. Okay, just a sec. This is, there we go. This is this. Okay, it's an a plus 3. It's a binomial. Okay, so this is, okay, when we multiply by the reciprocal, okay, when you have numbers like this, okay, a binomial, every number can be just written over 1. So when you have to write its reciprocal, so for example, if I had 7 and I asked you to write the reciprocal, okay, this would be 7 over 1. So then the reciprocal is 1 over 7. Okay, so this is the same thing. This is a, okay, binomial, okay, that when we multiply by the reciprocal, that's where the 1 came from. All right. All right, and so now that this is on the bottom, we would have to state any new NPVs. Because there's a lot of chatter, and unless you're working ahead and you're already done all the notes, okay, you're either doing that, okay, or you're, you know, I've seen a couple people who are ready to grab a textbook, that's fine, or you're following along with me. Okay, were there any new NPVs introduced? Okay, because this binomial is exactly the same as this one, there actually were no new NPVs. Okay. So now we're ready to multiply. So we have an a minus 6 on the top. We have a 3a on the bottom, and we have an a plus 3 and another a plus 3. Okay, we couldn't simplify that anymore. Like we couldn't cancel anything out. Okay, another way of writing this, because there's 2 of them, we could do this. 3a plus 3 squared. Okay, because there's 2 of them that are exactly the same, which means that it's squared. Okay. Yeah. A cannot equal 0 or negative 3. Okay. No, they get multiplied together. They only cancel out when one's on the top and one's on the bottom. Yeah, good question. All right. Okay, example number 2. So this is something that you would see as a numeric response question. Okay, so just be careful when you're reading it. It wants to know the number of non-permissible values, not actually what they are, just how many there are. Okay, so similar, we had a similar type of question when we were doing multiplication. But in order to figure that out, guys, you have to go through the majority of the steps. You still have to simplify. I mean, like factor. You still have to factor, because that will help you pull out your NPVs. Because it's a division, you still have to multiply by the reciprocal to check for any new NPVs introduced because of the new fraction. Okay, so for this, you would need to do x minus 3, pull out a GCF of x, and so we have x plus 5, okay, divided by 2x minus 7. This is a difference of squares, so x plus 6, x minus 6. So right now, our NPVs are x cannot equal 0. It takes care of the x. Sorry, this is a lovely 5. Okay, x cannot equal, here I'll write them all out. Okay, x plus 5 cannot equal 0, so x cannot equal negative 5. And then we have a plus or minus 6. X cannot equal plus or minus 6. Okay, so right now we're up to 4 NPVs. Okay, we're not quite done yet because we still have to do our kiss and flip. So we have to show times, okay, x plus 6, x minus 6 goes on top, and this 2x minus 7 goes on the bottom. Okay, guys, we've just introduced a new denominator. We've just introduced a new NPV. So we have to solve for that one. Okay, 2x minus 7 cannot equal 0. 2x, okay, cannot equal positive 7. Okay, so let's count them up, and there are 5. Okay, we don't have to finish the question. We don't have to simplify. We don't have to solve it anymore because we just needed to find out how many NPVs that there are. So there's 1, okay, there's 2, 3 and 4, and then 5. Okay, when the rational expression of this thing is simplified, okay, you just have to find the equivalent expression and its NPVs. So guys, sometimes what they'll do in a question like this, so when you're doing this question, just read it very carefully because these two answers are These two answers are exactly the same, except one of them has extra NPVs. Okay, so don't just go to the first, like if you find an equivalent one, don't go to the first one that you see because it might just be a distractor, right? Double check any NPVs. So like, again, my suggestion is you work through the question first and then go to the answer to compare. Okay, so for this one, I would factor first. I'm going to pull out a GCF of an x, and I'm left with an x plus 3. On the bottom, we have a difference of squares. So x plus 5, x minus 5. Okay, we're still dividing. We have a monomial on top. We have a GCF on the bottom. We can take out a 2 from both terms. So we're left with x minus 5. Okay, our NPVs. Okay, we have x cannot equal plus or minus 5. Okay, that takes care of these two, and it actually takes care of that one. Okay, the 2 we don't have a problem with, so just 2 NPVs right now. And then we're going to kiss and flip. All over x. Okay, so this is the important stuff. Don't forget, we've now introduced a new non-permissible value once we've multiplied by the reciprocal. Okay, so the answer has to have at least 3 in them. Okay, now we can like simplify here. We've got an x here and an x here. So I have 2x plus 3 all over x plus 5. X cannot equal 0 and plus or minus 5. Okay, how are we doing over here? Okay, so I would have chosen C. Okay, so B might have like interested me, but it didn't have all the NPVs because it missed it from when it did the reciprocal. All right, final question. Okay, again, guys, like just make sure that you know all the methods, right? Factor, NPVs, then you're going to kiss and flip, then you're going to do new NPVs, then you're going to simplify. Okay, so do this one and then go and grab your textbook because we have 4 questions, okay, for practice work that we're going to do. If you are one of the individuals who has not yet sent me your homework check, tisk, okay, get that done and get that in. Okay, you want to show me rather than take a picture? Yeah. Okay, give me a sec. Okay, I'm going to finish off this example for you guys. Okay, we're factoring now to 15x, and then we have a 2x plus 1. Difference of squares on the bottom, x plus 3, x minus 3. We're going to factor out an x squared. So we have a 2x plus 1. And we can factor out another x. So we have an x minus 3. Okay, NPVs are going to be x cannot equal plus or minus 3. X cannot equal 0. Now we can kiss and flip. Okay, we've introduced another factor on the denominator. So we have 2x plus 1 cannot equal 0. So we already have x cannot equal 0, so that one's fine for that one. the negative 1/2 takes care of the second one. Now we can simplify. My favorite part. All right, so we're left with 15 on the top and x plus 3 on the bottom. And it wants to know, so a is equal to 15, b was equal to 3, and it wanted to know a plus b, which gives us 18.